Copper and silicon are cooled from 300 Kelvin to 660 Kelvin. Cooled. Copper, positive temperature coefficient of resistance. It's a metal. Silicon, negative temperature coefficient of resistance. What do you mean by positive temperature coefficient? Cooled. As temperature decreases, resistance decreases. In the case of copper. In the case of silicon, negative. As temperature decreases, cooled, resistance increases. Increases in both. Decreases in both. No. Decreases in copper. It's mentioned cooled. When it is cooled, resistance decreases. So decreases in copper. No. It's mentioned increases in copper. Students, similar question was also asked in Karnataka CET and Comment K. For more such tips, subscribe our class. Do you want to learn more tips and tricks from previous year question papers of CET and NEET? Go to Google Play, download Rclass and purchase the course on CET and NEET. You will learn tips and tricks from all the chapters of 11th standard and 12th standard. Prepare well for your exams. Which of the following acts as a circuit protection device? Fuse. Charge flowing through a resistance R varies with time as charge equal to AT minus BT square, where A and B are positive constants. Charge. The total heat produced in R. So to find heat, we need current. So differentiate. Current equal to A minus 2BT. Differentiate A. Differentiate this T square 2T into B. So this is expression for current. Now, heat energy is I square R into T. So dt in small interval of time, because this current depends on time. To find out total heat energy, integration. And we have to find the limits of integration. At time t equal to 0, 0, 0, Q equal to 0, and then current is also equal to 0. So at time t equal to 0, time t equal to 0, 0 is the limit, current is 0. Now, substitute current 0 here. Consider this equation. 0 equal to A minus 2BT. So at t equal to A by 2B. At this instant also current equal to 0. So current equal to 0 at time t equal to 0. Current equal to 0 at t equal to A by 2B. So upper limit is A by 2B. Now we have to solve this. Let me keep R outside. I square, here is I square integration A square plus this square 4b square t square minus 2ab 2 into a into 2bt into dt. Of course, limits are from 0 to a by 2b. Or I have to integrate this. A square. So it is a square t. 4b square t square t cube by 3 minus 2 to 4 ab t square by 2 t square by 2. Limits are from 0 to a by 2b. Now R. Be careful. A square into T. A square into T is A by 2B. Plus 4 by 3. B square. T cube. T cube. A cube by 8B. A cube by 8B cube. Minus 4AB. T square. 4AB by 2. T square. T square is A square by 4B square. Now simplify carefully. A cube by B. A cube by B. A cube by B. 4, 4 gone. Half. Half. This get cancels with this. So we are left with only this. So it is A cube. A cube. B square B cube is B. 4, 1, 2, 6 into R. So A cube by 6B. A cube by 6B. So that is the heat energy liberated. Of course, it's a time consuming problem. And we can't use any other shortcut method. Why means, see, A cube by B into R. A cube by B into R. Even we can't use dimensional method. So of course, we will find few questions like this where we may have to kill some time. And if you can identify that such type of questions will kill time, in examination, drop the question, go to some other problem or question, solve. Finally, at the end, if you have time, come back and solve. Two cities are 150 km apart. Electric power sent from one city to another. Fine, one city to another. The fall of potential per kilometer is 8 volt. 150 kilometer, 8 volt per kilometer. It is 150 kilometer. So product of these two. 15 120 1200 volt. The fall of potential difference is 1200 volt. The average resistance per kilometer. So this is voltage. Resistance 0.5 ohm. 0.5 ohm per kilometer. There are 150 kilometers. Or there is 150 kilometer. 150 into this is, half of this is 75. 75 ohm. So resistance is 75. What's the expression for power in terms of voltage and resistance? V square by R. V square by R. 1200. So let me write this as 1200 square by resistance is 75. 12 square is 144 by 75. 144 75 10 to the power of 4.